In today's lesson, we are going to have a look at an example for the application of quadratic functions. Now, what I want to focus on in this particular example is some tactics about handling some complex problem-solving questions when it comes to quadratic functions. So let's first start by reading the question. So ball is thrown upwards from a building and follows the path given by the equation h equals minus x squared plus 4x plus 21. The ball h is a meters above the ground when it is at a horizontal distance of x meters from the building. So the first and foremost thing, there are two variables in this question. H, which is the height above meters, above the ground, the height above the ground, and x, which is the horizontal distance from the building. Now let's think logically about these two variables. Now height above the ground. The height above the ground in most normal circumstances is going to be a positive value. And x, which is the horizontal distance from the building, again in most logical circumstances is going to be a positive number. So which means the first conclusion that I take from the question is when I go about drawing a graph for this function, I'm only going to have the positive section of the x-axis and the y-axis because of the limitations for the variables. Now the second foremost thing, at the end of the day, it is a quadratic function. So when we talk about quadratic functions, we talk about all the important points that we can label in a quadratic function. So what are the most important points? We can have our y-intercept, our x-intercept or intercepts, our turning point, and finally the shape of the quadratic function. Now to start with, let's get rid of the most easiest one, which is our y-intercept. So working out the y-intercept, we substitute the value for x as 0, and that gives me the value for the height as 21 meters. So from this particular information, I can gather that when the ball is first thrown upwards, it is started to thrown upwards from 21 meters. Now let's go ahead with our x-intercepts. So working out our x-intercept, we make in this case y, which is h, as 0. So which means we have minus x squared plus 4x plus 21 equals 0. Now in order to factorize this quadratic function, I need to first get rid of the negative in front of the x squared. So I'm going to take a negative outside, which means I'm now going to have x squared minus 4x take away 21 equals 0. Now I have the value for a as 1, b as negative 4, c as negative 21. A times c gives us negative 21. So we're looking at two numbers that multiply to give us negative 21 and which will add to give us a minus 4. The two numbers are minus 7 and a positive 3. So which means our quadratic function now factorizes as x take away 7 times x plus 3 equals 0. Now applying our null factor law, there's only one possibility that when we multiply two different brackets and the answer is 0, the possibilities are x take away 7 equals 0 or x plus 3 equals 0. Now solving these two equations, I get the values for x as a positive 7 or we get the value for x as minus 3. Now let's go back to the variables again. Now x is the horizontal distance from a building. Now again we talked about its limitation. Its value cannot be negative. So the only value we can accept in this particular scenario is a positive 7. I mean, if it is a normal quadratic function without any application, we can accept both the answers. Now let's go ahead and sketch this function. Actually, before that, we still need to work out a turning point. So to work out a turning point, we take halfway between our two x-intercepts. So we got -3 and a positive 7. I'm going to do my working out for my turning point here. So halfway between the two x-intercepts, so -3 plus 7 divided by 2 gives me the x-coordinate of my turning point as a positive 2. We substitute that into the function, so -2 squared plus 4 times 2 plus 21 gives us -2 squared is 4 plus 8 plus 21, which gives us the y-coordinate of the turning point as h equals 25, which means the coordinate of the turning point in this case is going to be 2, 25. Okie dokie, with that information, we can now proceed to sketch this quadratic function. So as we note in this scenario, my y-intercept is 0, 21. So let's note down the points here. So I've got 0, 21. My x-intercept, the one that we can accept in this scenario, is 7, 0. And my turning point is going to be 2, 25. Now, going back to the quadratic function, obviously the leading term, which is my x squared, is a negative term, which means the shape of the quadratic is going to be an upside down U, where our turning point becomes the maximum. Okay, so looking at the graph, I need my x values between 0 and 7, and I need a maximum y value of 25. So keeping that in mind, let's mark our axis. I'm going to go 1, 2, 3, 4, 5, 6, 7, and that is my horizontal distance in meters as per the question. My height, we need a maximum of 25, so we're going to go 5, 10, 15, 20, and 25. Again, we've got to label that axis 2, that is my height, which is again in meters. Okay, so labeling my first point, I'm labeling my y-intercept, which is 21, so I'm going to roughly mark it there. My turning point is going to be 2, 25, so we mark our turning point. And then we mark our x-intercept, which is 7, 0. And now that we've done that, we can join it with a beautiful looking curve. And that completes the graph of this quadratic function. Okay, let's go ahead and answer some of the questions. What is the maximum height the ball reaches? Now we're going to look at our turning point, which is going to be 2, 25, and the maximum height, which is my y-coordinate, tells me the maximum height the ball reaches is 25 meters above the ground. Going on to the next section, how far is the ball from the wall when it reaches the maximum height? So this time we're talking about the horizontal distance when it reaches the maximum height, which in this case is going to be 2 meters from the building. And finally, how far from the building does the ball land? As we can see in our graph here, the ball lands 7 meters from the building. And that completes the question here. Okay, like again, let's focus on the core basics of a quadratic function. You know, all the important features of a quadratic graph is going to help us solve any word problems or any application problems. Have a lovely day, students.